Here's where the multi-leader gets spicy. This is time when the interviewer questions you what happens when two leaders receive conflicting rights. Let's take an example. So, for example, if at 2.0 the page title is distributed systems. Now at T1, Alice from the US data center changes it to distributed databases and the US leader accepts it. Now at T1 at the same time, the Bob from Europe data center changes distributed systems to distributed storage and the Europe leader accepts distributed storage. Now do you see the conflict here? US leader has distributed databases and Europe leader has distributed storage. Now this is a conflict. Either ways, both rights are accepted by the respective leader and both are valid as well, but they're incompatible. So the system has to choose, and there are multiple strategies and possibilities which we can use, and here we will discuss about those. Now the first strategy is last right wins. This is one of the most common strategies, but it can be a really problematic when there are timestamps that are located in different parts of the world. Here, something like if Alice writes at 1000 milliseconds, the timestamp, then Bob's write at 1001 millisecond, automatically the one with the higher timestamp is chosen. So as per the earlier example, we'll choose distributed storage. But the problem is Alice's write is lost and this is a data loss. I think this should be used when the writes are independent. So for example, we are using a shopping cart where the loss is acceptable. It's fine, the person can add it again. So that's not a problem. The next strategy is application level conflict resolution. I think this is one of the best strategy and we can use multiple strategies here. One is maybe on the read and another is on write. So in case of read, that is like DynamoDB-style, the databases store both the conflicting version. And when the user reads, the application receives both the versions. The application shows to the user there are conflicting changes and which one do you want. And the user can choose in that case. Some of those applications that use it are Amazon shopping cart. If you add an item on the mobile and a desktop offline, both will appear when synced. Another way to use this is on write, but this is used by CouchDB. When the conflict is detected during the sync, it triggers a custom resolution function, and then the function decides either it needs to merge it or choose one of them. So if you see in this code, we have a function called resolve conflict. It checks the priority. If one of the priority is higher, then it will choose version 1. Otherwise, it will merge both the versions. Next strategy, we are going to discuss about conflict-free replicated data types, that is CRDTs. This is one of the most advanced way of resolution and it is used by one of the most advanced data structures like Redis, Riak or Figma for collaborative design. So CRDTs are advanced data structure and mathematically they cannot conflict. Let me give you an example. In case there is a counter and we want to store the values, instead of storing counter A is equal to 1 or 2 or 3 directly, it will write something like this. Increments Alice 3 and Bob 2. That is, the counter has been incremented by 3 by Alice and then by 2 by Bob. Similarly, for the next decrement operation, Alice incremented by 0, Bob incremented by 0. So at the end, it will do a total, that is 3 plus 2 minus 0 plus 0, which is equal to 5. So both Alice and Bob can increment independently. When sync, these counts are added. Another example is of setting a value. So for example, Alice has set a value for a variable to be x comma y. Then Bob's adds y comma z parallelly. They are doing it concurrently. So inherently, it will decide the conflict and merge it to x, y, z. So here they are merging both the values together by deciding the values from both the users. The next strategy is operational transformation. This is very commonly used by Google Docs. So let me give you an example. Suppose there is a text in a Google Doc called hello. Alice at the same time insert X at position 2. They're considering it 0 index. So 0, 1, 2. At 2, they have inserted X. At the same time, Bob sees it and deletes the X. So what will happen is that the OT will check the values and analyze it, and based upon its cognitive intelligence, the final value will be hello. So this is the advantage of using OT. It cognitively decides what to be used based upon the dictionaries it has and the understanding, and by using machine learning models. Okay, let's discuss about all these strategies and some of the advantages and disadvantages. The last right wins strategy. The advantage is that it is very simple, no need of complex algorithms to be required. But the con is that the data loss. It is used by Cassandra and Riak. There's an option to choose last right wins while installing Cassandra and Riak on read resolution. So the pro is that there is no auto data loss, and the con is the burden is left to the user to decide which version to delete. It is used by Amazon DynamoDB. Next is on-write resolution. The advantage is that it is a very flexible kind of strategy. The disadvantage is that we have to write complex logic. It is used by CouchDB. Then the data structure of CRDTs. The advantage is that there will be no conflicts ever. The limitation is that it has a very limited data type. It is used by Redis and Riak. And then the last strategy is OT, operational transformation. It is great for text, but it is very complex. It is used by Google Docs. If in the interview I have to answer about which strategy to use, I would say for conflict resolution, I'd first try to avoid conflicts through the application design. That is by using partitioning of data so different leaders handle different data. If the conflicts are unavoidable, I'd use CRDTs for data types that support it, like countries or sets or counters. Now, for complex data, I'd implement custom conflict resolution on write for storing metadata like vector clocks to detect conflicts, and for applying business logic to merge. The last write wins is a last resort due to the data loss.